Hello and welcome to Gin with Gwyn. Now, normally you get off the cuff and unrehearsed thoughts from me, but today I'm sharing a presentation I recently did for the ETF. Who are ETF? They are an amazing non-profit organization that aim to provide training and insights into industries for higher education level lecturers and staff. And they asked for a subject matter expert about the world of analytics and analytics careers. And so naturally, they could not find anybody good to speak, and I ended up giving this presentation. And I've got some hot takes for you today. Cool. This is about 50 minutes long, in case you don't want to watch this. So the three big goals for this presentation are to explain how does data actually work, how do data professionals actually work, and what are the gaps, challenges, and opportunities. Does Oliver know things? If you're subscribed to this newsletter, then you know the answer is probably not. I did growth marketing for 10 years. Data was always my strategic advantage. I was always doing things in a data led way. And I switched to data about 5 years ago and won a load of awards since then because I had the subject matter expert, but I also know a bit about data. And today I am a data strategist at 173 Tech. You might be wondering, what is data strategy? Well, I don't believe that there is such a thing as data strategy. There's only business strategy and how data ladders up to it, which is something that I should stop saying in presentations because I'm going to make myself unemployed if I keep saying that. But that is fundamentally the biggest divide that I see in analytics and analytics careers today, in that there are two sides of the coin. There's subject matter expertise, which is understanding the context, rhythm, and actions that you can take in any day to day of any job. And there's analytics knowledge, understanding the hard maths and statistical outputs behind that. And one of the problems today that I see is that data people are expected to have both. They're expected to understand operations and finance and marketing and procurement and business in general, but they're also expected to know data engineering, modeling, visualization, analysis, and storytelling. And it's a push and pull which is creating a lot of problems. About 29% of practicing data scientists say that lack of domain knowledge affects them often or always. 49% say that projects start without well framed, domain informed objective. And so it's perhaps not surprising that 85% of data projects fail to non technical reasons. So the solution isn't adopted by stakeholders, or it doesn't have the effect that they need because it doesn't ladder up to their day to day and the real decisions and behaviors that those people can make. On the other side of things, the technical side of things, so 42% of data and analytics respondents said that a shortage of people is a major obstacle to AI readiness. And I would say 90% of companies that I meet on a day to day basis are nowhere near ready for AI. And in terms of communication, about 20% of respondents say that performance is not good, despite 89% of them saying that it's an important thing. Last but not least, job requirements list 119 distinct analytics tools as desired competencies, and that's a lot of tools for any few people to get their head around. Now, it might seem odd today where analytics is a high paid profession, it's in demand, people are fighting over good analytics talent, and trust me, there's a big gap between good and bad. That I would say to you that analytics as a career, I think, is under threat, but it's because of these five things. The first is that companies are just not seeing value from their data. Everybody talks about it, but the reality is very few people are crossing the bridge because very few people have stakeholder knowledge like I have to be able to say to the marketing department, this is what the data shows. I know how to make an ad. I can do this. This is what you need to do. I have the experience to back up what I'm saying. You need to change on that. And that is a fundamental gap that I see time and time again. Second thing is that wages boomed in 2022. After the pandemic, there was a real competition for anybody and anyone with analytics as a skill. And so the whole industry, or every industry, became saturated with low level talent who didn't have as much experience as other people. And those people were highly paid at the time. And so what that does is it creates, from a business stakeholder point of view, which is how I look at things as somebody who's come into analytics, it means that analytics people are expensive. The other side of the coin is that data people have unrealistic expectations placed upon them. They have to have those technical and subject matter skills that I was talking about. AI makes analytics look incredibly slow as a process, and I guess it makes everything look slow as a process. But stakeholders don't care how the sausage is made. They just want a number on a dashboard, or they just want a number on a report. And they want the number to be right, but often they don't know all the work that goes into making the number right. They don't know about cleaning the data, modeling the data, and staging the data, and then visualizing the data. And they get a number or some SQL from ChatGPT or Claude, and it works. And they don't realize that that query might not be optimum. And so it costs them more money to run every time, or that query doesn't take into account the way that the data's been structured. And so they're getting a different version of the truth than everybody else. This is a problem even without AI in terms of ad hoc SQL. Last but not least, finding data talent is very difficult depending on the tools you select, the area that you're working in, and the role that you want to outline. And that means that data people from a business point of view today or in the future, I worry will be seen as ineffective and expensive, which is a dangerous thing. So, how do we navigate these challenges? The first thing is the right technology. So you've probably seen a lot of data tool stacks like this. This is the one that all the tools that we at 173 Tech recommend. And I would like to point out that we are tool agnostic, but we do have a preference towards cloud and open source technologies. And this is something I'm sure you've all seen before. How does data work? You've got your data sources, you extract it, which is sort of making a copy of the data or a selected copy of that data if it's available. You put it into a data warehouse, which stores it all for the future. Within your data warehouse, you then do some modeling, which is where you apply your business logic onto that data. And then that is fed into reports, it's fed into analytics and machine learning, and it's fed back through reverse ETL back into the sources. And all of this is orchestrated, which is like a to-do list of when these processes should take place, and version control helps you understand who did what modeling at what time. Here's a better explanation of how data is modeled, because that is the most important part of this that loads of people don't understand. So you have your data sources, you have a raw layer, which is a direct copy of the source data stored in your system for further processing. Then you have intermediate tables, which is a schema that organizes, joins, cleans the raw data, applies logic to make it more accessible. Then you've got production models, which stores metrics and dimension data, the basis for analysis, reporting, and data science models, and visualization tables, which is data optimized for dashboards reporting and ensuring that the insights are actionable. Now, that seems very straightforward, doesn't it? But the problem is that most tool providers today are trying to become a black box. They're trying to do a little bit of everything, despite most data people not wanting them to. So here is Power BI. It's a reporting tool. But Power BI can also do data modeling with something called DAX, which I don't like. And it can do a bit of data extraction, and it can do a bit of ML, it claims. But if you pick Power BI and you decide to model using DAX, that means that your talent base that you can hire from is significantly smaller than if you pick other tools. And DAX does some strange things, and it's not necessarily the most scalable of tool. And so you shouldn't pick one tool that does everything. But from a business stakeholder point of view, you go, well, this one tool can do these four things, so why should I pay for four different tools? One tool that was not on my original list because I don't like it, Azure Data Factory, similar thing. It can do data extraction, it can do data modeling, and it can do version control. But it does data modeling by click and drag, basically. And so it can only model very, very basic metrics. It's meant for non-technical people, but that means it's not scalable. It can't do more advanced metrics. And so if you're relying on Azure Data Factory, you'll never get to the good stuff in data that we all want to get to. So pitfalls for companies are companies rarely think about how their technology affects hiring, and it can have a huge effect, the technology that you pick, on how big the pool is that you can fish from. Switching out all-in-one products that claim to do everything can be very costly because they definitely try and tie you into a SaaS model. We've had a few people on Clean that we've migrated, and they've saved a lot of money doing that. SaaS models make data very expensive in general because the more data you have, the more expensive they you get, and that hurts ROI from any investment in data. And from a career point of view, tying your career to one technology is incredibly dangerous, obviously, with so many different tools out there. It takes significant time and energy to learn such a wide variety of tools. But what I often see, apparently, especially from people who are joining analytics as a career or they've just left university, is they do a lot of qualifications, they do a lot of certificates, and it's a good use of their time rather than doing nothing. But does it mean anything? Just because you've got a certificate, it just means that you can pass an exam. It doesn't really mean that you know those tools. And so my career advice on technology is SQL is the primary skill you will need for all modeling. Modeling is the most important thing in data, and it will be for 20 years' time. I pretty much guarantee that. Second thing is, especially if you're starting in data, the principles do matter more than the specifics, by which I mean it's great if you can learn Power BI or Metabase or whatever, but the principles of how do you make a good dashboard? What information do you put on there? How do you organize things? How do you make sure that the colors contrast nicely? Those principles are more important, in my view, to learn if you're in higher education or university. And last is nothing beats hands-on experience. So, courses are good and stuff, but having real projects with real business data, there's nothing that's going to beat that. That's the most important thing. So while spending time on certification is good and it adds to your CV, having real projects makes a big difference. The next bit is the right people. So this is our approach to sort of data. We choose the right metrics, we define those metrics in a data dictionary, just a document that says where does the data come from and how do we model it. We automate the extraction process for the data that we need for that. We then translate it into core concepts. We then combine and transform data from different places into data models. We reconcile a model against the source of truth, and then surface it as charts and self-serve dashboards, and then train the team to use the solution. And historically, this was a number of different people on the pipeline. So maybe your business stakeholders did this first two bits, or maybe somebody like me. Then your data engineers did the automation, analytics engineers are the people who did the modeling, and then maybe a data analyst just made the charts and then fed that back to the team. But today, and going forward for the next 5 years, the lines are getting blurrier. We are seeing that data analysts and analytics engineers, there's not much difference to what they're being asked today. It used to be that they just created dashboards if you were a data analyst, but today you're probably doing a bit of data modeling as well. And data scientists and analytics engineers, they both used to do modeling, but now they're being asked to do machine learning and AI. And data engineers and data scientists, they used to be asked to do this more advanced modeling, but now they're also being asked to create pipelines. And so the lines are blurring between the roles. And the reason for that is that more small and medium sized businesses are entering the market in terms of hiring data talent. More and more startups and scale ups are realizing that, hey, data can really make a difference. And so, over the last sort of 10 years, what we've seen is that historically only the big companies could afford a large team, so they had a competitive advantage, and that scaled. More people have had a small team, but really the big rise is that there's more and more standalone roles in the world of data. And so you get more analytics generalists in the field. These are the 2024 starter salaries. So people just entering, or maybe they've got 1 to 2 years experience. I'm afraid this is in USD, even though it's for the UK, over the last 5 years. And what we see here is that there's been a nice steady incline in terms of wages. But we also see this bottom one here is the London cost of living, or the average cost of living, that's also risen here. So while data salaries are still a high paying job, when you're first starting out, there's not much of a gap. It's still difficult to sort of live there. Data scientists are still the highest paid in the UK because we've got a lot of those in London. Because there's so many new people entering the world of data, there's more demand for data engineers, which shows a lack of maturity in the data market here. And data analysts have kind of squared off a little bit over the last 5 years. In terms of amount of jobs, or average amount of jobs per month, this is probably true of every career in England. We have a huge divide in the country where London has 10 times job for most jobs. So this is not crazy, but you literally have 10 times more people for data scientists in London than Manchester, for engineers and for analysts. And for the rest of the country, there's a huge divide there. I wanted to look at this a different way. So I looked at the average population. Now, obviously, not all of them are data people, but how many jobs were there per population of these people? And so for London, we've got one job per 2,520 people. Average starter salary was £35,000, and the average cost of living is 22,000. Manchester, 902, one job per 1,992 people, 30k average starting salary, 16k cost of living. Edinburgh, one job for 1,363. Edinburgh, very financial analytics base, starting salary a little bit low, 28K. The average cost of living 18K, a little bit more expensive to live in Edinburgh than Manchester. Cardiff, one job for 1,091 people, starting salary of 30K, average cost of living lower at 15K. And Birmingham, which is one of the hottest places in terms of wage rises in the last 5 years for data people, but one job per 2,484 people, starter salary lower than London at 29K, but the cost of living also low at 19K. So, in terms of choosing the right pathway, London has 10 times the opportunities, but the competition is also higher, and so is the cost. Places like Edinburgh are heavily tied into one sort of industry, like finance. Manchester is heavily tied into advertising. But being near jobs has serious long term benefits when you get past the first few years of your career. So, and this is true of most places, that if you already live in London and you don't have to pay rent, you're going to have a strategic advantage in your career for the long term. The pitfalls are that experience will differ massively depending on the size of the company typically. Bigger companies can offer significantly better training and learning opportunities, which is the number one thing to preference. The lines are blurring, and so you're expected to know more about the whole pipeline, but technology can help there because so many more technologies are trying to do a bit of everything. So the bit that you're weak on, they can potentially help on. So my career advice about career paths is that understanding concepts is the most underrated skill in data. And what do I mean by that? I mean that a lot of data people that I've encountered, they will understand how to code, but they don't understand that, okay, for MRR, I've got the concept of subscriptions, I've got the concept of customers, and I need these two concepts, and then I can figure out from there the data and how to model that. Understanding the broader concepts of where does the data come from and what do I need to understand is something that's really, really underrated in terms of career paths, and something that is not taught as often for people who are learning about data. For new starters or new entrants into the world of data, learning and mentorship are the most important thing to look for above anything else. That's what you should be preferencing, and not wages or not the size of the organization, which does have an impact on training. But who are you going to learn from, and do they really have time to teach you? And then coming back to this thing about practical examples on your portfolio that will really help you to stand out in what is a competitive market, even though demand is high. Last but not least, the right strategy. So here's some pretty bold predictions for today versus 5 years' time. So today, analytics profession are well paid, even in smaller companies due to a lack of talent. But in 5 years' time, I expect that salaries are going to fall as SaaS tools will make adoption easier after there's an initial hurdle. What do I mean by this? I mean that today, the SaaS tools that claim to do all of your analytics, they do a bad job generally. Don't trust people who claim that they can do machine learning or predictive analytics. I've seen them, they've all been absolutely terrible. You will make terrible decisions based on them. But in 5 years' time, they might get good. I can see certain jobs like uh, the automation of extraction getting better and better to the point where you might not need to know that. And so I expect that salaries will fall because you'll need to know less of these niche things. Today, many greenfield sites, in terms of there's no analytic structure, there's nothing in place, are apparent in medium and small size companies. But I think, and this is maybe true today, most people could start with data and get core reporting sorted with varying degrees of messiness in place. And that means that from day one, you can have probably all of your accounting set up and automated for the for foreseeable future. All of your marketing reporting probably done easily without relying on GA4 or internal software. Today, standalone analytics roles focused on providing answers, but I actually see in the future that we're going to get more and more hybrid roles that are going to mix analysis with implementation directly. So you'll get more people like me who not only do they have to look at marketing data, they have to then go and act on that marketing data. I think we'll see data becoming more and more a part of implementation roles and less as a standalone role. Last but not least, the latest buzzword in the world of data is agentic, which is AI going and doing a load of stuff for you. It's not a good idea, people. I will do another blog on this, but you can't offset key business decisions to a black box that you have no accountability for, you will get fired, I think. Everything is AI today, even when it's not, even when it's just machine learning or SQL. But very few machine learning projects are actually deployed. Trust me, I see most people's data. Not many people have machine learning, or what I would consider true machine learning, where you have a number of different models that are all interoperable and working together towards a greater answer. Very few people are doing that at scale. But in 5 years' time, I think that robust machine learning becomes the norm and we get above normal sort of reporting. How can we prepare for this future? So, the first thing is fundamentals, good quality code that is well documented, star schemas, DBT. This is the fundamental that everybody needs to know if they want a career in data. Understanding of concepts, modeling, which is the main thing, plans and pipelines. Understanding of visualization best practices. So, the fundamentals that you need in a career for analytics. The next thing on top of that is subject matter, but that doesn't need to be such a niche that I think that people are asking for today. It needs to be, do you understand how businesses make money and where the money is? Because if you understand that, then you will work on things that will make money. What decisions and actions can people actually make based on the data? And then you will work towards things that will ladder up to that. And what is the relationship between data and actually doing? Because you can surface a lot of data, but if you can't do anything with it, then what's the point? And then after that, I think to have a career in data, what you do is you niche down, and you niche down on subject matter, you niche down on company area or business type, subscriptions or e-commerce or something like that, or you niche down on a particular problem that you know inside and out, like segmentation or predictive analytics or something like that. What would I do if I was you? Now, I'm not talking here to you as an analytics person. I'm talking to people who are teaching the next generation of analytics people. So there's 5 things. The first one is I would focus on the quality of modeling above all else, which I think is also useful if you're thinking about or starting or early in your career of data. Spend your time to learn modeling. That's the thing that will keep you in a job forever. Number 2 is I see when people apply for jobs a lot of like government or social level analytics projects in their portfolio, which is like, look, let's look at how many blind people there are or how many earthquakes, and that's really nice and stuff, but it doesn't apply to 99% of businesses. It shows some skills, but really, I want to see that you can do the thing that you're going to be doing in a job. And so I want to see if I'm going to hire you to do marketing analytics, I want to see some marketing analytics projects. And synthetic data is a thing that exists. So if you've not got on your portfolio something that matches the sort of jobs that you're applying for, then that's a gap to me. The next thing is start playing a game of so what with students. So internally at One Free Tech, I like to say so what 4 times on everything that we do analysis wise. And it works a bit like, okay, so this advert is not working, or so what? So, well, we should stop running it. So what? So what we've learned here is that this keyword to this demographic doesn't work, and actually what we need to do is this. So what? So now what we need to do is change the actual campaign towards that and launch that, and then in 2 weeks' time we'll see if it works. So what's the actual action that you need to do that, and how does that impact the bottom line? It could also be, for example, we're thinking about selling to enterprise clients. So what? Well, currently we only have 5% of enterprise clients. So what? So what is that we find that they cost £25 to acquire versus £10. So what? So that means that we need to have a marketing budget that is 2.5 times more than the regular people that we acquire if we want to attract the same amount of people. So what? Well, how much money do they bring in, and so on and so forth. Number 4, stakeholder management is not a soft skill at all. And so when you are learning about data, you need to team up with different departments. So if you with somebody who does marketing, if you're with somebody who does PR or whatever it is that the data is, team up with different departments and see what really matters to them, because that's the important thing in data, is that it actually impacts other people and what they're doing. And if you don't understand the context of that, it's really difficult. So stakeholder management is not a soft skill at all. 20% of people say that they're not doing a good job of communication from data. Most people do not understand data. And so communication is something to really, really work on. Because if you can't persuade somebody to take an action, then you're going to be ineffective. If you're ineffective, you're a very expensive resource and you will not have a career in data. Last but not least, and this is for colleges or universities, think about the SaaS tools or funding SaaS tools after people have left. Because often what I see when people are applying for jobs is they did a data project and all they can show for it is like a screenshot of a dashboard. And that is not anything to me. That could be completely fake. I don't learn anything from that. And so having live examples of stuff and having live access to the code is really, really important. And I guess, okay, it's a small cost of users to the university, but it would make a big difference to people who are applying for jobs. Here's some useful links at the end of my talk. And that is my presentation on analytics careers. And I guess just to undermine all of this, I think analytics as a career is in danger because right now, business owners are seeing that you are expensive and you're ineffective. And the way to counteract that is not to try and learn everything about business processes and try and learn everything about analytics or just focus on one area and ignore another. It is to go back to the fundamental first principles of how do people make money? What do they do to make that money? How can data inform the things that they can do to make more money? And if you do that, then that's good. Focus on modeling and focus on communication. Thanks very much for watching. Tune in next time for some more Jim with Gwen.